So with the Mbed API, we can control a PWM output using the PWM out class. So watch here how it's written. It's written in camel case. So PWM starts with uppercase P, lowercase W and M, and then uppercase O. So it's controlled by this PWM out class. So we create a PWM out object, and then with a constructor, and we specify which pin to use. So it's very important you only use P1, P21 to P26, or LED 1 to LED 4. You know, if you try and use a PWM class on a pin that doesn't support it, then you'll get a message. So an error message will actually be sent over the serial port, and also the onboard LEDs will start to flash. So if you see though, there's a particular pattern there flashing when an error has occurred. So if you try and upload some code, and when you run the code you get this particular pattern, you know, that's more likely caused by you trying to use a specific class with the pins that don't support it. So it's very easy to use. It's very easy to use this class. So we use this period method to set the period of the waveform. So there's no method actually to set the frequency. So in this example code here, because I've created a variable called frequency. So this is a float, set the value 100. So the period, you know, I'm actually doing 1 over the frequency to define the period. So that's going to set, well, it's going to set the period to be a 1 over 100. And then inside the while one, we're going into this while one loop, and I'm going to loop through the duty cycle. So again, the duty cycle is this is a value in the range 0 to 1. So what corresponds up to 0% up to 100%. So in this for loop, and then looping, essentially looping from 0 up to 1 in increments of 0.1. So we'll start off with 0. We'll write using this .write method. We'll write 0 to that, so it's going to sense at the beginning. It'll switch off 0% duty cycle. It'll switch off the LED essentially. Then we'll wait for 0.2 seconds. Then we'll go to the next value in here. So that'll be, because of this increment, it'll be 0.1. So we'll do 10% duty cycle. Wait for 0.2 seconds. That will get incremented. 0.2, 0.3, 0.4, 0.5, 0.6, etc. Then when we get to 100% duty cycle, we'll reset back to 0. So you can see here the LEDs are going to start from off, and they go up in 10-degree increments until it gets to fully on. It's just worth pointing out that all PWM channels share the same period. So here, even though I'm just using pin 24 in this example, I'll set it to 0.01. That will apply to all the pins. You know, if you had other, because you can have multiple PWM objects. We could have, you know, maybe for a green LED or a blue LED or whatever. You know, each PWM object can have a different duty cycle, so you can use a write method on each one to give it a different value, but they all share the same underlying period. It's just worth keeping that in mind. So in the previous example we saw we could set the duty cycle, but we can also define the pulse width using the pulse width method. So in this example here, so this is scientific notation, so this is 5 times 10 to the minus 3. So we need to, when you use pulse width, it needs to be a floating point number. So we'll set that to 5 milliseconds. Or you can use, if you do pulse width underscore ms, that will specify the pulse width in milliseconds, but then the argument is actually an integer. And we can also use microseconds as well, so like underscore US. So again, that's integer. So all these 3 lines of code do exactly the same. So these are all set the pulse width to be 5 milliseconds, so we can either specify that in seconds, milliseconds or microseconds. But just be wary that the milliseconds and microseconds must be integers.